is wide on the panels. The panels are 20 feet tall and 15 feet wide. And it got even more fun because it's a cantilever truss. The support's there. Where's this truss? This truss would be a truss that you would do if you want to cantilever floor out of the building. It would look like it's punching out. So it's got 2 kips down, 4, 8, 4, and 2. What kind of a truss has no diagonal members? A Virnel. You were close.
Box.
Yeah. Box equals Virnel. Well, it's not a Virnel. Huh? Virndel. V-I-E-R-E-N-D-E-E-L. It's a Dutch word. No diagonal. So, joint A, B, C, D, E, F, G, H, I, and J. Where would you like to start? Don't we need to find the reactions? Okay, so we gotta find the reactions. What are the reactions? We got 2, 4, 8, 4, 2. Figure it out. You gotta figure it out. I'm sorry? We'll make it. That's from the roller. Okay, so just like we did with beams, sum of the moment has to equal 0. These will stay with you this semester and next. And that's if you're a 3+, you can use the nice ball too. Forever and forever. That's how long. So I'm summing about here. I have 2 kips times 0 feet plus 4 kips times 15 feet plus 8 kips times 30 feet plus 4 kips times 45 feet plus 2 kips times 60 feet minus 45 R2. You solve that and you get that R2 equals 13.3. Summing forces equal to 0, and you get that R1 is equal to 6.7 kips. So this is 6.7. This is 13.3. So the sum of the moments lives on in trusses. The moment strikes.
Why were there 2 of the 45?
There's 2 at 45. Oh, this?
Yeah.
R2 is the reaction right here. So it's negative. That's what we're solving for, is that reaction.
Oh, yeah.
Why is it 45 feet?
Yeah.
15, 15, 15 reaction. That's counterclockwise, so it's otherwise you don't have all your loads taken care of.
Make it accurate rather than setting
I always like to take everything to the tenth, so I wouldn't round it. Unless it were like 515.1, no one's going to miss the 0.1. But when it's small numbers like that, I always carry it. Okay, so where do you want to start? Let's start at F. So up at F, we have two kids down, AF and FG. What is the force in FG? 0, and the force in AF? In compression. 2 compression, 3 0. So, where do you want to go now? Let's go to A. Now this is where geometry comes in. It gets really, really fun. So this is what I've got. I have 2 kips coming down because I have 2 in compression. 2, I've got AB and AG. And my triangle is now a 15-20 triangle, which you could divide it by 5 and call it a 3-4 triangle, because that's a lot easier number to play with. So that's a true 3, 4, 5. Okay, so what do I know? I'm sorry? Huh? 3 and 4. I divided 15 and 20 by 5. Why did I do that? Because 3 and 4 are a lot easier to play with than 15 and 20. You can leave it. Because it's not 1 to 1. You remember the previous ones, these were the same dimension. You know, so it was a 1 to 1. Now we have 15-foot run and 20-foot rise, so it's not a 1 to 1 anymore. So some of the forces in the vertical direction, I always start with vertical if you haven't noticed. I've got 2 down, 6.7 up, means I've got to have 4.7 down. So I've got a horizontal force pushing that way, and it's equal to not 4.7 because we're not 1 to 1. So how do you figure out what that is? You use cross multiplication. So I've got 4.7 all over 4 because 4.7 relates to the foreleg of my triangle. And that has to equal the horizontal force divided by 3. So I can cross multiply. I've got 3 times 4.7 equals 4 times the horizontal, or the horizontal is equal to 3.5. Cross multiplication. How many of you did cross multiplication in high school? Everybody understand this? Important first step. You get it? You don't get it? You get it? Yes, no, sometimes. So if I've got 3.5 horizontal going that way, some of the forces in the horizontal direction, I got 3.5 to the left. AB has to be 3.5 to the right. Intention. The force in AG then is 4.7 squared plus 3.5 squared square root, or 5.1. And that's in compression.
Is that a square root, 4.7 squared?
That's 4.7 squared plus 3.5 squared square root. Where do you want to go to next? Hold on. Hold on. Let me know when you're ready. Okay, I'm going to go to joint B. Yes.
Real quick, if say they were odd numbers, it was like the height and width was like 7 and 11. You would still use cross multiplication to figure out.
Correct.
All right.
So the question was, if I have a triangle that is 7 and 11, and I've got a force that I know, let's say 3, and I want to find out the horizontal, it's going to be 3 is to 11 as the horizontal is to 7. So I'd have 21 equals 11h, and then I would just solve for h. Doesn't matter whatever the proportions are, you just do it the same way. Okay, what the question was is, what's the 5.9 for? If I have a vertical component of 4.7 and a horizontal component of 3.5, the resultant, the true force in that member is 5.9. Correct.
Wait, how did you get the 5 point?
4.7 squared plus 3.5 squared square root. Pythagorean here. Okay, joint B. At joint B, I have this. I have 3.5 extension. BC. So there you go. What's the force in BG?
0.
What's the force in BC? Tension or compression? So where do you want to go to next? Home. That sounds like a great idea. Finish it for homework. It's not. It's cantilever, so it can't be hard. You got to do every member. So what I want you to do for homework is. So they want to go home. They want to go home. How many people want to go home? How many people want to stay?
Wait, but which one needs to go home?
Huh?
Which one needs to go home? Stay.
Well, no, because I'm never going to be able to finish this anyway.
Let's think about it.
So I want you to finish this, and then I want you to design the members using Doug for 1.